Hey you guys, we're back. We're continuing our discussion on graphing logarithmic functions. And just like on the previous video, if you have any questions, feel free to get a post-it note, put it on the board with your question on it, and be as specific as possible. Or you can hit me up on Edmodo, and I'll try to get you an answer as quick as I possibly can. Matter of fact, I'm trying to get into a habit of leaving my account active so I can see your questions when they pop up during the school day. Now, after 4 o'clock, hey, I'm answering them when I can. So we're looking at second example, negative log base 3, and I'm gonna quickly go through it because I went through part of it on the first video. And so step 1, like I said, we're gonna find our x-intercept. We're gonna substitute 0 for y, and what happens here is we go from here to here because we've substituted the 0 in right here. And so after we substitute 0 in, now we're going to add 1 to both sides, and that gives us 1 equals negative log base 3 x plus 1. So from here we're going to divide by negative 1. And remember, I said dividing by negative 1 gets this negative from this log right here, because we don't want to have to fool this negative too much longer. So now we have negative 1 equals log base 3 x minus 1. So now we're going to apply our switch method. When we apply the switch method, we have this becomes my exponent, this becomes my base. So now we have 3 to the negative 1 power. And so 3 to the negative 1 power goes down to 1/3. And so now we have 1/3 equals x minus 1. So now if we would add 1 to both sides, we have 1 and 1/3, or we have 1.33. So my x-intercept is 1.33, comma 0. So now we're going to substitute for our y-intercept. So same principle, we're going to substitute in 0 for x right here. And so now we have negative log base 3 of negative 1. And since there's no log of a negative number, there's no y-intercept. And a lot of times you're going to get that. And you can really look. If you look at this right here, if your x is negative right here, so you have x negatives to a number, you know, you can really look at that for a dead giveaway. So now we're going to look at our asymptote. And under our asymptote, you know, h is negative 1. So remember, for asymptote, is x equals the opposite of h. So if h is negative 1, then my asymptote is going to be 1. So let's plot these points right quick. Let's find me 2 additional points. So here's my original problem. So with my original problem, we have we substituted in 2 for x right here. So we have 2 minus 1 that gave me 1. And then we work this thing out using this formula. And so we ended up with 0 minus 1 here, because what happened was we had log 1 over log 3. So log 1 over log 3 gave us 0. So 0 minus 1, this should actually be negative 1. So we're going to get back to where we were working. So this is where we are on our XY table. Like I said, we substituted in 2 for X right here. And then once we work this thing out right here, we got -1. And so this point is 2, -1. Now we did the same thing right here. So we substituted in 3 for X. When we substituted in 3 for X, we have 3 minus 1, which gave us 2. So we have log 2 over log 3. And so that gave us 0.6. So we took the negative of that. So we have -0.631 minus 1. So this is how we get this number right here. So let me walk you through this again. We have log base 3, 3 minus 1. So I substituted in 3 for X right here. So 3 minus 1 gave me 2. So since 3 minus 1 gave me 2, now we did log 2 over log 3 using the change of base formula. Log 2 over log 3. So we do log 2 over log 3, you're going to get 0.63. And because we're taking the negative of that, we brought down our negative. So now we have -0.631 minus 1. And that's how we got this -1.631. So now we're going to graph all of our points. So this is my first point I graphed. 1.33. 0 is my x-intercept. I don't have a y-intercept, but my next point was 2, -1. Then I have 3, -1.63. And so that's my asymptote, and there's my graph line. As you can see, we're looking at my graph, and see how I have a decreasing graph right here. So since my graph is decreasing, I do make sure I have to flip my range. So my domain, because this is negative right here, I gotta also flip my domain from -h infinity to what you see here is 1 to the infinity. And so, no, this is my h right here. The opposite of h, excuse me, the opposite of -1 is a +1. So we have +1 to infinity. Here's my range right here. And looking at my end behavior, we flip the range. So we have if x approaches 1, f(x) approaches infinity. And as x approaches infinity, f approaches -infinity. So I hope I was able to help you guys out a little bit. Like I said, if you got any questions, you can leave them for me on the board, and we'll go from there. Have a good one.